hello to everyone and welcome to Urbano Canalis Essential Training Day 2. My name is Rino and today we will continue where we left off yesterday. We will talk about theme mappings and queries, work with disk repository. We will talk about profile plotting, working with user data. We will talk about pipe crosses and clashes, export to BIM formats. We will draw and edit house connections and storm drains, and I will show some advanced options for labeling and profile editing. The session will last approximately 2 hours. We will have 1 hour and 45 minutes of live presentation, and after that we will have Q&A and discussion, and I will answer all of your questions. So let's start with the training. Here we are in Urbano where we left off yesterday. So basically what we did yesterday, we covered the majority of the functions here from the main Urbano workspace. So we basically draw everything in plan. We used many different label configurations. I showed you how to draw profile and precisely define pipe elevations or pipe invert elevations directly in profiles. I showed you how to assign pipes and manholes from the catalog, also how to define trenches, draw cross sections, and calculate excavation volumes. The next function that I would like to show you is the function for drawing the theme maps. This is really nice functionality, especially later on. You will see when we calculate hydraulic calculations and get all the results about flows, velocities, pipe fulfillment and stuff like that. We can basically do color coding and do theme mappings for various parts of the network with different data. Here again we have some predefined configurations, for example according to arrays. So if you want to run a theme map, again just double click on it. We have to select, I will select everything, I will set a legend position, and when I click show I can place it anywhere where I would like to have this legend. For example, let's put it here, and now in different colors we can see parts of the network that belong to array A1, we see in red, array S1, so this side channel, and also side channel number 2 in green color. And also here in the legend we can see number of sections in each array and total section length for the entire array. To delete it, just click here on delete and everything will be gone. The same thing can be applied for branches or, for example, diameters. Let's check the diameters that we defined yesterday. So let's place the legend here, and again in different colors we can see all these parts of the network, and this is always really nice because it's sometimes, especially with the large networks, and in Urbano you can have really large networks, this color coding can help you distancing some parts of the network by using many criteria, for example diameters or velocities or anything else. Okay, let's delete this one also, and let's now create one theme map of our own, and I will do it for the nodes. So to create a new theme map, click right mouse button and I will say new. Okay, first I will give it a name. I will say terrain elevations. Okay, and we have to define what is the mapping data. So I'm searching for terrain height. So you can search for it, or you can type it if you know how the data is called in Urbano. So it will be terrain height. Okay, and now we can define number of limits, number of ranges like this, or we can define size of this ranges, size of these limits. So I will say that the minimum is 0, let's say, maximum will be 50, and the size of each range will be, for example, 10. Okay, and this is it. Also, I would like to switch these colors other way around because I would like that the small terrain elevations are in this blue colors, cold colors, and high terrain elevations to be in warm colors. So I will just switch it. So from 5 to 1. You can also leave it like that, but I always like for this cold color to represent small velocities and this warm color to represent high values. And also for this block scale factor, because each node, because we are doing T-map for a node, we will draw some kind of block for each node. I will increase it to 5. So block scale factor will be 5. And also for the legend, I will increase text height also to 5. So it will be a little bit bigger legend. For the name of the legend, I will say terrain elevation. Okay. And for the value inside of the legend, I will use like this H terrain. Okay, let's click OK. And the theme map is created. We have to apply it now. So double click on it, select everything, click on show with set legend position turned on, and I will place it here. And that's it. Now we have also one really nice theme maps with the terrain elevation mapping. We can check the data of the legend. We see all these ranges, we see number of nodes inside of each range. So that's it. That's pretty simple for now. Later on, when tomorrow, when we run hydraulic calculation and get all the result of the calculation, we will also analyze and draw theme mappings for velocities and other stuff. Okay, to delete it, again, you can delete it like I showed you before, or you can click here on the main root of the function and just say remove theme mappings from the drawing. Okay, so these are the theme mappings. Let's also now check the queries. So queries are really more of a GIS function, but it can really be useful to use them also in design purposes. So to create a query, just again, right click on the command, you can click new, and now you can create data queries, so according to some data, or you can create location queries. So this can really be helpful if you are working with really big, huge networks. What we will do here is we will create few data queries. And again, you have to select a data according to which you will create a query. And let's do it, for example, for section lengths. Of course, it would be much more important to do it, for example, for some velocities or stuff like that, but we don't have such data yet. We will have it tomorrow. So I will show it, for example, on the example of the lengths. So I will use 2D section lengths, and I will say, okay, operator will be smaller and value will be, let's say, 15. Okay, and I will insert this query, this filter here to this part of the table. Also, we can give it a name. I will say sections smaller than 15 meters. Here in the data table, we can preview it. So we see that for now, all the section lengths from our entire systems are from 7 to 42. But when I run the query, now we see that we have here only sections that are smaller than 15 meters. Let's click OK, and let's see where else we can use these queries. For example, if we have this data previews, I will select the entire system. I will expand it a little bit, and we can check again. We have all the sections here from the smallest of 7 to the biggest of 42. Now, if you want to run the query, just drag and drop it with the left mouse button and place it here inside of the data table. Okay, and now we see that the query is applied and we have only sections smaller than 15 meters. If we run this marking plan option, we can see with this temporary graphics where we have these really small sections. Okay, let's now do something more complex. So I will copy this query. Of course, you can create a new one, but I always like to copy something and then edit it. So I will copy this query. Let's open it, and I will add another filter. So you can combine add or queries, And in this case, I would like to use or. And again, you have to select the data. It can be, for example, diameter or something like that, but I will again use the length. Okay, because I would like to search for all the sections that are smaller than 15 or larger than, let's say, 40 meters. Okay, let's add this as well. And here I will call it so smaller than 15, or we will say bigger than 40 meters. Okay, let's again run the query. And now we can see that we have this small section length, but also this big sections larger than 40 meters. Let's click OK. Let's again try it. I will select the whole system. So we have all the sections here. Let's take this query and drag and drop it here to data table. And now you see that again we have this smaller than 15 and also this larger than 40. If you have similar types of queries but just with different values, you don't have to create let's say 10, 20 queries. You can create something that we call dynamic queries. So again, I will create a copy, I will edit it, and I will switch here from dynamic entry from no to yes. Okay, and I will call it sections smaller than, I will put question mark, or larger than question mark. Okay, let's click OK and let's check now what does this mean. So again, let's select the whole system. Okay, and now I will use this dynamic query. So when I drag and drop it now, the software will ask me, okay, filter by value, but what is the value? Let's say I would like to see all the sections smaller than 10, but also larger than, let's leave it 40. Okay, and now we have only these sections here. And these queries can be used in many different functions throughout the whole Urbano. Also, in combination with queries, you can use this marking option, because I showed you this temporary marking that I said yesterday. If you want to delete this temporary marking, just type regen from AutoCAD or click on this Urbano broom to clear the temporary graphics. But if you want to mark something permanently, you can, for example, just run these markings. You can create different configurations for sections and for the nodes. Here we have some default ones, for example, a red dashed line, yellow solid line, and stuff like that. So if you want to have some permanent marking, you can just double click on it. And here you can select again parts of the network that you would like to mark. Let's say, let's mark this, and this section with the marking style yellow solid line. And when I click mark, this will be permanently marked. So now if I pick on a broom, nothing will happen. If I pick on regen, nothing will happen, because this is permanent marking. Of course, to delete it, just click here on delete. Or you can use interactive option and then pick on the sections, and wherever you pick, it will be marked in yellow. To delete everything, select the whole system and delete it. So this is the interactive way of using markings. But for example, if you ran a query like we did here, and now we would like to mark permanently all these sections that satisfy this query, you can just take it and again drag and drop it to the marking style. For example, let's drag and drop it again to yellow solid line like this. And because it's a dynamic query, this dialog will pop out. So we will say, okay, smaller than 10, larger than 40. Okay, and now these sections with the lengths higher than 40 and smaller than 10 meters will be permanently marked. And just imagine, for example, if you create query like that for velocities that are too high, or slopes that are too high or too low, or what else can we use? For example, when we run hydraulic calculation, we get pipes with pipe fulfillment that is too big and stuff like that. So for example, if you are collaborating with someone, you can do these markings, you can send the drawing to another user of Urbano, and then he can maybe intervene or change something. Okay, so let's delete the queries. Again, I showed you how, not the queries, but the markings. So you can also, just like for the theme mappings, you can right click here on the top root menu and remove marking from the drawing. Okay, so during yesterday's session and today, we created some of our own configurations. And now I will show you how you can use them on your other projects. So because everything you create in Urbano, all these configurations and templates, they can be used forever on all of your other projects. And of course, you can even share them with your colleagues or project members. So everything is saved inside of DWG. That's something that I already told you, but also you can save it to disk, to application. And that part of Urbano about this Urbano user interface, we have disk repository. So if you created something of your own, or if you change something and you would like to transfer it to another drawing or give it to someone without giving the DWG file, or if you just want to store it for later usage, you can again just drag and drop. I will drag and drop this my section data table to disk repository. Let's also take my section label and drag and drop it below. You see that it is saved here. Let's do for all these configurations that we did. So we changed this configuration for long sections. Let's drag and drop it here. We created one auto invert calculation configuration. Let's put it here. Okay, we did this theme map for terrain elevations like that. We did all these queries. Let's do this as well because they might be useful sometimes. And also we created this my plan style. Let's drag and drop this as well. But also, let's say that we created the system template. So we would like to have this as our system template to start the next drawing. So not just the configurations, but the whole system template can be saved. You cannot just drag and drop the system. That's not how it works. But you can right click on the system name and click Save as Template. And you will also see that this will appear now here in the disk repository. You can rename it. You can give it another name. For example, I will call it sewage template like this. And now let's say I will save this drawing, but again, I will not save it as working because I would like to send you the initial files and the final files. So I will save it. And I will save it as, let's call it not working, but final. Okay. And let's now open another drawing. So another drawing, blank DWG file. Again, we are at the beginning. We are starting the new project. You see that the main workspace is empty, but our disk repository is full. And now you have two options. Again, you can create a new system according to system templates from country kit. For example, I will run sewage, and you will see that this looks exactly the same like yesterday where we started the training. But now you would like to use some of this. Again, just drag and drop my section data table up, and here it is. You can use it. You can use it on this project. The same is for labels. The same is for everything. Here it is now, my section label. Let's do it also for my plan style. Okay, and that is it. But also, if you want to create a new system from your system template, you can do it, but it's not located here. You cannot create it from here, but here it is in the disk repository. You pick on it and you can create for yourself many different templates. You can create, for example, template for a sanitary system, for storm system, for some kind of drainage, for water system, for some dry utilities, for anything. And now when you want to create a system based on this template, right mouse button on it and create system based on this template. And it is here sewage novi because that's how the system was. So be sure that when you create templates, also give it some name, but it doesn't matter. You can just rename it like I showed you yesterday if you go to edit. But that is it, and you can see that now the drawing is empty, but this looks completely the same as the as this main workspace looked in our project that we did here for Urbano Canalis final. And if you want to share this disk repository with your colleagues, I will show you where this file is located. So again, you have to go to C, Program Files, Studio Rs. You will have only once. I have multiple versions here, but this is the one that I use, the latest version, Urbano 10.2 on AutoCAD 2022 version or Civil 3D. So language version of Urbano. So version 2021 works both on 2021 and 2022. Okay, and now if I just sort these files by date modified, here it is. This is the application repository XML. So this is the sewage template. This is the disk repository file. It is called application repository. And if you want to share it with someone, you can just copy it. You can give it to your colleague and he can just paste it in this same location. The same goes for all the files that start with catalog. So yesterday I showed you catalog of pipes, manhole, trenches, and upper layers. So if you create your own items, you will see that the date modified will change, and you can copy these files you can give it to your colleagues or project members. But just these files, do not copy some other files because you will mess something up with the installation. So catalog files and application repository can be copied to other computers. Okay, so let's go back now to our system. We are not done yet, even though I renamed it to final. And let's see what else can be done. So I said that everything is saved inside of the DWG file. So let's, for example, open some other drawing, some older project that I did. I will open this project that I did for the webinar, Urbano Canalis webinar that we had a few weeks ago. And I will open this drawing just to show you that everything can look completely different. So here, as you can see, I have some different configurations of the labels. We have some completely different styling of the profile. And somebody yesterday asked if you can put multiple terrain lines. And this is the answer, yes. So in the gray, you can see this is the newly designed finish ground, and this in green color, it is the existing ground. And you can show up to 10 terrains in the profiles, as we told you yesterday. And also, this is something that we will talk also today. This is the pipe crossings and pipe clashes that also can be shown automatically. But the thing that I would like to take from this drawing is these configurations of this manhole schemes. So this is really nice function. It is located here also in the main workspace, here under manhole schemes. And I created one configuration to look like this. And I really like what I did here. So I will just drag and drop it and paste and leave it here in the disk repository. Okay, let's close now this drawing. You don't have to close it, but I don't need it anymore. And now inside of this drawing, I will just take it. So I will use this manhole scheme configuration and I will drag and drop it here. Okay, let's find it. It is here under manhole schemes. And this one with the suffix P, this is for prefabricated manholes. So in the entire project, I'm using manholes from the catalogs. But also we will not talk about this, but just for information, In Urbano, we also have prefabricated manhole elements. So basically, you can build your own manholes with predefined prefabricated elements like bottom part, ring part, chamber part, manhole cover, and stuff like that. So this prefabricated, I don't need them, so I will delete this from my drawing. I don't need these configurations. And I have some that are default ones, one in scale 1 to 50, automatically prepared for plotting on A3 paper, and also this one that I take from another drawing, so I will use this one. And again, you have to select everything or parts of that you would like to draw these manhole schemes. I will define row spacing and column spacing. Let's click on draw and let's place this, for example, here. And in a matter of seconds, we get this 60 something manhole schemes, and you can see all this data here. You can see the plan view, you can see the profile view, and everything is hatched, everything is labeled, and like I said, everything is inside of this configuration. So just like for the profile, just like for the cross sections, you can define what data will be shown. You can define this styling information about manhole shape in plan, about manhole shape in profile, and also you can even draw this this scheme, but it is not included in this configuration. And also this table data with some of the information at the bottom. For example, you can check all the information about the current manhole, manhole before, manhole after. You see all the terrain elevations, invert elevations, what are the sections connecting those manholes, and also entering and exiting pipe diameters from each manhole. So really, really nice functionality. Okay, the next thing I would like to show you is how to work with user data. So in Urbano, you already saw that we have many data, really huge amount of data, but always sometimes you need some data that is not predefined in the software. For example, this can be some GIS data or some data that you need for construction purposes. So the data that you would like to assign to your model to go to BIM model. And all this data, you can create it. You can also store it for later usage. And also you can use it like any other Urbano data. We call it user data, but they are basically arbitrary data, or in Civil 3D, for example, they call it property set data. But it's not property set data, it's our own, we call it user data. So it is the icon here next to the catalogs. You can pick on it and you can create any data. So let's, for example, create one data. So I picked here on new. You can give it a name. For example, I will call it year. Now you can define, is it integer, so whole number, is it the text, or is it a real number with decimal places? I will say integer because it is year. Description, I will say year of construction. Okay, for the default value that will be automatically offered when you want to assign it, I will say 2021. Okay, I will not use predefined data. I will leave for free entry. And now for the topology, you can set up this or you can leave it empty, but it is good because you can filter for which elements and which system types this user data will be available. So for the topology, I will use line net topology. This is networks. Polygon is parcels, and non-topological elements are some assembly schemes and stuff like that for water system. But we will use line net topology. Topology type, you can say, okay, it will be for sewage, for water, for gas, for vacuum, or you can just leave it empty, so it will be for all pipe networks. For entity type, you can again say, okay, it's for section, it's for node, or for catchment area, or you can leave it empty, which means it's for everything. Okay, and I will leave it like this. Okay, now let's create another one. So again, I will click here and I will say name will be, let's say, pipe status. Data type, let's call it text now. Description, I will say let's say condition of the pipe. Okay, and default value, I will say it's excellent because it's a new network. So let's leave it as excellent. So this is just a default. And also we can set some predefined data. So if you turn this on, you can set the list of all the possible answers. So I will create 5 possible answers and I will say, okay, it will be excellent. It will be, for example, very good. Let's put good also. Let's put bad. And let's put need replacement. Okay, needs replacement. Let's click OK. And again, it will be for line net topology. Because I said it's pipe status, I will limit that this will be data that can be assigned only for the sections. Let's click OK. And now we see in this hierarchy, we see this data, everything is for line net topology. This is for sections, this is for everything. But also I can edit it and I will say, okay, but no, it will be just for sewage systems. So you will not be able to see this data and assign it in water systems. But it's up to you. This is pretty general data, so the best way would be to leave it empty. But just to show you, I will put here sewage. And now you see that the hierarchy of the data changed. So this is now sewage data for the sections, and this is the data for everything. Okay, let's click OK. And also, you can store this data for later usage. It's basically like a catalog. So this is the part of the drawing. It says current drawing. And if you want to save it for your other projects, just pick here, copy to application repository, and now it is here. So when you start a new drawing, this will be empty, but this will be already here, and you can pick on it and just bring it back to your current drawing. So let's click OK. And let's now assign this data. So basically now this data is treated like any other Urbano data, which means you can assign it, you can preview it, you can put it in the labels, you can put it in the data tables, you can put it in the profile tables, you can export it to various file formats, you can export it to BIM formats, and basically it's treated like any other Urbano data. But you have to assign it to network elements. So to do it, of course, we have to go to input data and we go to user data input, as you see here. And now we have the data for the sections and the data for all entities. Okay, let's click assign for the whole system. First, pipe status. So let's say that everything is excellent and just click save. But for example, let's change here on this branch, or let's say on this bottom part, these two parts, these two branches, I will switch from excellent, and you can see I cannot type something differently. I can only use from this list of predefined elements, of these predefined values, and I will use, okay, here is not excellent, let's put it to good. Let's click save. Okay, and maybe for this last part, let's put it to needs replacement. Save. Let's say this is some old part of the network. Okay, and for the year, again, I will select, let's select maybe these two top branches. Let's say these are the new parts of the system. And here I will say 2021 as it is the default value because that was offered by the software. Save. And now for this part and this part, let's change it from 2021 maybe to, let's put 1980. Save. Okay. And for this last part, let's put 1971. Okay, and let's click save. Okay, so the data is now assigned. Let's check them. Let's create another data preview table, or we can add it to one existing, but I will create a new one and I will call it user data for sections. Okay, data selection icon. Just double click on the group for adding all the data. And here we see pipe status and year. Let's click OK. Let's double click on this data table. And here it is. We see pipe statuses, we see years, we see everything for this network that we created. So basically, you can also use it for some GIS purposes as well, because if we select something, for example, let's select this, we can get the information that basically we created that was not in the software from the beginning. Okay, let's do it also for the nodes, because we assigned some of the data for the nodes as well. I will say user data for nodes. We go to icon for data selection, double click on user data. We have only year, because we said that the pipe condition is only for pipes and year is for everything. Okay, it is here. Let's click OK. Let's open it. And here it is. We have all the years here. Let's also put it in the label. For example, let's create one section label. You can create new section label, or you can use some of the existing ones. Let's take the one that we created yesterday, my section label, and let's just copy it like this, and let's edit it. I will call it user data label. Okay, and I will delete all this data. You can delete it from here, or you can also go to data selection. You can select the first one. You can press Shift button on your keyboard, and you can delete all of them at once. And I will add this user data, so year and pipe status. If you want to change the order, you can pick on it, and we will have first pipe status and then the year. Also, let's decrease the text height from 1 to 0.8 like this, and let's click OK. So new data label is created. Double click on it. For the entire system, let's label it. And now for each section, you see that you have the status of the pipe and also the year of construction. But like I said, it can be any other data. It can be some data that you would like to see maybe for construction purposes or something else. Also for editing of this data, I already showed you. So you can go to, again, to function for input data, user data input. You can select something and you can basically just change it. So this is one way how you can do it. Or again, you can use your data tables. I like to use these data tables because they are really dynamic and interactive. And let's switch here from my section data table to user data for sections. Let's here select this branch, and you can see that this is all the white cells. And we learned yesterday that the white cells means that you can directly edit them from the data table. So you also see this temporary marking to mark your current section. And here I will say, okay, it's not need replacement. You cannot double click on it because it's predefined data type. So you can choose it only from the drop-down menu. And I will say, okay, it is, let's say, only bad because it's built in, let's say, 1975. And you can see how the label is automatically changing because, like we learned yesterday, everything is completely dynamic in Urbano. So the whole model is updating and refreshing. If you change something in the data tables, in the profile, in the plan, everything reacts and automatically updates. Okay, so this is about the user data. And let's now talk about the plotting of the profiles. I don't need this, let's call them GIS data in the labels. So let's put back this my section label. Let's double click on it, select everything, and let's apply it. Okay, and we are back where we left off before. Okay, so let's now plot the profiles. When you are plotting the profiles, it's a matter of how big your paper is, but also how long is your profile, and also how the terrain is changing, because you can have a really short profile that will probably fit by length on one paper, but because of the really steep terrain, it cannot fit on the paper because the paper height is too small. That's why we have really nice automatic functions for preparation of profiles for plotting. First of all, you can, or you don't have to, but I always like to do it. I like to define my layout. So I will delete this predefined layouts by AutoCAD. Okay, I will delete this, and I will edit this paper. So to edit the paper, I will just go to Page Setup Manager. And so this is optional. You don't have to do it, but I always like to have some paper here, because if you don't set up the paper, Urbano will still plot your profiles here, but the paper won't match. So that's why I like to match the paper before, but you can also do it later. So we will go to Modify. For the printer or plotter, I will select DWG to PDF. I always like to first plot it to PDF and then plot it to my plotter. For paper size, I like to create custom paper sizes, because usually these profiles, usually we plot them on paper rolls, and I created a custom paper with basically Plotter Manager AutoCAD functionality, and the length of the paper is 91.4 centimeters, and the height of the paper is height of A3 paper, so 29.7. I will use this. And now for the scale, because we used the scale like I told you yesterday, I like my profiles to be smaller than planned. So that's why I have to use here 1 millimeter is 0.1 unit. But if you are using your profiles in millimeters, like I showed you, it is possible, you will leave it 1:1. But my profiles are smaller, 10 times smaller than the plan. So 1 millimeter is 0.1 unit. Okay, that is it. And the paper is created. Here in the catalogs, you also have catalog of printing frames. So something that you will probably not edit, but I will just show you where this is located. So here we have this papers. Basically, you define only the paper height, because the width is something that will be calculated. But here you see the paper height can be defined. So we have A4 papers, A3, A2, A1, and stuff like that. And now I will close this. Let's now prepare these profiles for plotting. So to prepare them, you can go here to Ribbon and start the function for drawing frames, or like I said here in the main workspace, you can go to the function for, it is called draw frames to layout and layout plot setup, these two functions. But I always like to use Ribbon. So draw frames, and here, this is a little bit, you have to know how this works. Basically, you have to select the profiles that you want to plot. So we will plot only these 3 profiles. I don't need these ones because they are just the same as these ones, but drawn from node to node. And now, basically, you have to define what is the paper format. This is the paper height, and this is from the catalog. So I will use height of A3 paper, 29.7. That's simple. But this is now important. What is the maximum width of the this frame that will go to layout? And here you have to know few stuff. How this is calculated, I will show you by opening calculator. So basically our paper size, we said it's 91.4 centimeters. So 91.4 centimeters. You have to reduce by the margins of the paper. So we have 2.5 on the left and 0.5 on the right. Also, I like to have some space on the paper so that not is everything too clustered. So I also add 1 centimeter to have some spacing on the paper. And also you have to reduce by this table header width. So let's reduce also by 8 point, let's round it up to 8.2 like this. And this is the available space on the paper, 79.2. So we will type this 79.2 here. Okay, so that is it. Also now we have to we can define some other parameters, but I usually left them default. You can overlap these frames to the previous node, but I don't like this. I use this frame overlapping of 1 unit. You can increase it to more. You can set maximum overlapping to, let's say, 10 units. Additional space above terrain, I like to put, for example, 5 units. Because of this, sometimes you can have the labels for the manholes, or this, as you can see, this this information that goes above the terrain surface. So I will say additional space above the terrain 5. And now when you click draw, you see the software automatically draws these helping frames. And now from this point on, everything is clear because the software will place this into your layouts. So let's do it. The other function is draw frames. So sorry, not this, but frames to layout. And here again, you have to select which ones do you want to plot to layout. I will say this one, and this one. Okay, so you have to select to which layout. We will go to layout 1. Layout name, I will say layout name based on the profile name. Okay, we can draw each this red frame to its own layout, but I don't like this. But I like this new layout for each long section, for each profile. This is something you want to use. And also this, so limit frames in layout by width. Yes, that's it. And what is the maximum width? So now we calculated the maximum width of these red frames, but we also have to say what is the maximum free space on the paper. Because on the paper, you can have some of your custom blocks. For example, you can have title block. You can have something. So you have to define here also what is the maximum space on the paper. Usually, if you don't have any title blocks or something, but also if you have title blocks, you have to include it here as well, because then this red frame will also be shorter. Okay, this is a little bit more complex function, but when you start to use it, you will start to appreciate it as well. So how to calculate this? So basically, again, we have our 91.4 paper. We have to reduce it by paper margins, which is 2.5. And also now we have to just define the insertion point, which is the half of the that space that I left off, because I said 1 centimeter, it will be 0.5 on the left, 0.5 on the right. So this is it. So and also I think I didn't, so it's 91.4 minus 2.5 and minus, okay, 0.5 on the right and 0.5 for the spacing. So 87.9. So it is here 87.9. And the distance between the viewports, because the software will automatically create AutoCAD viewports, we will say 5, and offset between the view and the scale we will put 2. Okay, we will draw common frame for all viewports. And like I said, if you have some title block, you can also draw title block by inserting it automatically here, but we will not do it. So click here on create layouts, and that is it. So it's really good function, really powerful function, really easy to use, but okay, you have to know how to calculate this paper widths. So let's check it. So this is for the first one. This is for the, okay, it didn't fit. So it didn't fit here. So it had to go to another paper. So A1, and then we have S1 and S2. Okay, so this is the function for plotting of the profile. Okay, so now we will switch to something else, and that is the talk about the pipe crossings and pipe clashes with other infrastructure. To do this, we obviously have to have some other infrastructure. So let's do it. I have here another Urbano project. So let's go to it. And this time, this is a water project created with Urbano Hydra. So if we just drag and drop it here to command line, the project will open, and I will quickly show you this water system. So like we said, Urbano is for all kinds of pipe infrastructure. You can use it for sewage systems, storm and sanitary. You can use it for water pressure systems. You can use it also for the dry utilities and gas systems as well. So this is the water system. You can see that everything is defined. We have the pipes, we have the manholes where they go, we have all the labels, and also we have all the profiles. And now I will show you how you can merge these projects together in one DWG file. Just imagine if you work in a company where you have multiple designers, and one designer will do one part of the project, another designer will do another part of the project, or one designer will do water, another designer will do sewage, and at some point you have to merge these projects together to check them for crossings and clashes. So to do this, you have to export it to Urbano XML file. The function is located here. So export topology to Urbano XML. Okay. You have to decide what you want to export. So we will export this water system. Let's define where we would like to put it. Let's put it here in our working folder, Urbano Initial. Okay. And let's just save it. Export it, and the file is written. And that's it. You can send that file. This is XML file, but Urbano XML file. Do not confuse it with Land XML. It's our own XML file. And now we can import it to another drawing. So let's close now this water project. Let's go back to our newly designed sewage system. So here I will go to same function, but now for importing topology from Urbano XML. Okay, let's select the file. And why this function is great? Because it will not just import the system in plan. It will import all the profiles. It will import all the labels, everything, all the trenches, all the pipes, all the manholes. And as you can see, everything is perfectly fitted on the right location. And here we see also now we have the profiles of the water system. And now that we have something overlapping here and crossing here in plan, or in this case clashing, you will also see that the profiles for both systems automatically updated. So let's check. This is, we saw these profiles before in the drawing where we had only water system. There were no these labels here. And now we see that the program automatically computed and is showing this pipe crossings and pipe clashes. So you can see the distances between the pipes, but also graphically we see that we have a clash between pipes and manholes. You can see the relative position of the pipes, and this is for the water system that, let's say, did one designer. And also let's zoom to our profile. Our profiles for sewage system that we did. We also have the relative positions of the water system, and in these labels you can see which system this is, what are the nominal diameters, what are the distances, but any other data. So this is just the default. You can also put this label to be somewhere else. For example, you can define that the label is here or below or anything else. So it's just the matter of styling, but the point is that everything is being calculated automatically. If you need more data about it, because let's imagine these are not these small networks, let's imagine these are hundreds of kilometers, and you would like to check all the crossings and test it for clashes. To do this, let's go to the special panel, which is called intersection analysis. And here you can go to intersection preview. This is a special data table where you can check all your pipe crosses and pipe clashes. Here we see in different tabs, pipe with pipe, we have 12 crossings. And if we sort it by distance, we can see which of them are real clashes and which of them are just crossings. Also here, if we scroll to the right, we can see which ones are in direct collision. Okay. And also if we switch to pipes and manholes, we can see clashes between pipes and manholes. So obviously this is something that we will have to do something about it, because we cannot go into construction with this type of the project. So and also we have manholes with manholes, but fortunately we do not have such issues here in this project. So what we can do now, we can start and moving and editing our systems to resolve these problems. So we can go one by one. And of course, always it is easier to change the water system, because water system can really be more flexible. So in this case, let's now imagine that we are the water designer, not the sewage designer, but it's basically the same. So now you see that here in this, I will close this dialog. You will see that here we have two systems now, and we will be at the sewage system. And let's now move these nodes a little bit. So I will take the move node functionality, and basically I will move this node and put it, for example, here. So we do not have a clash here. And also I will do it for this node as well. Let's do it like this. Also, I will move this node a little bit and put it here. Of course, when you are designing this, you will be more detailed than what I'm doing here, but you get the point. Someone has to fix their crossings and clashes, and it has to be either a water designer or a sewage designer. At any point, you can go back to your data table and check what we did. So let's go to intersection preview, and we can see that the numbers are going down. So now we have a lot less pipe crossings, and if we sort it, here we have only one pipe clashing. So here it is. So let's move this water manhole as well. So I will move it a little bit down, and you will see that everything will disappear from the data table, but just select everything again. And now we see that we do not have pipe clashes anymore. So we have only pipe crossings like that. And you can see that here, this red column, this is for the sewage system, and this is for the water system. So if we also scroll to the end of this table, you also see a relative position between these pipes. And this is for the system number one. So the system number one, as we see, the first one, the red one, is sewage. So this is really important information, because we know that every time the sewage system is below water system, this is really important information. And also we can check everything. You can check for distances. We can also go to check these pipes and manhole, and here is still distance 0. So we still have one clash here, and this is between pipe and the manhole. So the best thing would be to just move this. This is a node. This is a place where we didn't assign a manhole in water system. So that's why the software is not, this is just a circle, just some block. This is not the entity, the element in 3D. So this is not a clash. This is just some graphics. But I will move it, for example, to be like this. Okay, Let's now again select everything in the data table, and there is no more clashes. So now our model is completely clash free. And also it is important to say that all the pipe crossings and all the pipe clashes are basically calculated in 3D. So even if we don't have the 3D solid style applied, as you can see, these are plain AutoCAD lines or blocks, we can click here to draw 3D. And now when we auto zoom to these elements, you can see how the program is automatically drawing everything in 3D. So if you switch to 3D view in AutoCAD, we can see that the software is basically searching everything and calculating the distances between two closest 3D faces. So this is the distance. So if we open AutoCAD properties and check the length of this shortest distance, this is it. This is the length of 145, 146 that is being shown here. So that's how the software checks for the distances between the pipes, the very same way how Autodesk Navisworks is checking for the shortest distance between the sections. Okay, let's close this. Let's go back to 2D view. And now I will save this file. Okay, and let's open another file. I will open file where I have now 4 different pipe infrastructure systems from Urbano. So let's say that we designed everything. We don't have time to design all these 4 systems. But again, it can be the same way as we did it before. One designer or one company can do sanitary, one water, one drainage, one system. And here, if we go to our system selection, we have these 4 systems. Also, another great way how to check all of your systems in your drawing, you can click here on this quick info and select system summary. And here we can see about this system. So we have the total number of nodes and sections for each of the system. And also we have one new system which is empty. This will be our newly designed system in this drawing. Okay, first of all, let's check what we already have here. We are located in the sanitary system. You can switch between the systems. And here I have the configuration for drawing of the profiles. I will draw the profiles for the entire sewage system at once. So just click on select everything. According to arrays, we can put them into rows and columns, and we can define row and column spacing. Let's put it to 20, like this, and let's click on draw. Let's put it to this point here. I have intentionally some point here. You will see later why. It's just for the presentation purposes. You don't have to have a point. And this is it. Basically, in 1 second, we draw all these profiles. And like I showed you before, all the crossings are automatically calculating and showing in all of your profiles. So I just draw the profiles now for the sewage system, for the sewage sanitary system, but the profiles, the crosses and clashes are automatically calculated for everything, for all the systems that you have in your drawing. It's just a matter of what you have, what profiles you have drawn, and also what styling do you have inside of your configurations. I previously draw all the profiles for all other systems, but I just hide the layers. So let's just turn off now all the layers. You can do it, you can just go to each of these systems and turn all the system layers by picking here on this yellow light bulb, or you can click here again to system summary. You can select all these systems and just select this turn system on or off. You can first turn it off and turn it on, and now all the system layers are turned on. We see that we also have some catchment areas here, but we do not need them. So let's just turn off the layer with the catchment areas. And now we can see that I have all the layers here. Also, if you are going to work with this file, I prepared some layer states here, so you can just switch here to all profiles and restore it, and that is it. I also put these descriptions so we know which profiles are from which system. I showed you it's really quick to draw all these profiles, but you have to switch to each of these systems and basically draw it. So I did this before just not to lose too much time. And if we zoom to each of these systems, each of these profiles, you can see these relative positions of other pipe infrastructure systems. If you want to put some labels in plan as well, you can do it. So let's go here again to intersection analysis panel. You can go to intersection label definitions. So this is special kind of labels. But if you went to add, you see that the dialogues are pretty the same as for the labels for nodes and sections. So you will know how to create your own labels. And also here I have some already predefined. So intersection point, intersection and position. So if we go to edit, you can see that again, you have to add the data. You can define some prefixes, text heights, basic stuff. Okay, so let's apply the labels now. You can go to intersection settings and you can just turn on automatic labeling. That's it. Select what the label will be and click OK. So this is just intersection point without the data. So you have these blocks representing just the crosses in plan. And why it is called automatic labeling? Because if you move something, the label will follow the crossing. And if there is no more crossing, the label will automatically be deleted. And if you draw something new label will automatically appear. That's why it is called automatic labeling. Also, you can switch to some other label, let's say this intersection. Okay, and now we will see much more data. We see the distance between the pipes, we see the terrain elevations at that point, and we see depths below the terrain of both pipes. So this is the pipe crown depth of each of the pipes. A lot of users don't like to see these labels in plan, so you can easily just turn this off and there will be no more labels. I showed you the function for the intersection preview already, but let's show it once more because it's really impressive. And here we have a lot more clashes and crossings that we had in the previous example. So as we learned, just pick inside of the data table, go through the data table, you are automatically zoomed because this option is turned on, and the axis and the crossing polygon is automatically showing here. And like I said, pipe with pipe, pipe with manhole, and here we also have manhole with manhole. So this is really nice. This is really important information as well. Okay, let's concentrate to pipe with pipe. You can have what system this is, names of the sections, nominal diameters, relative position, and basically any other data that you might want to add. So you can create, again, different configurations with different data. So these configurations, you create them here. So intersection preview definition, and you can create different previews. Just to show you, let's close this. Intersection preview definition, as this is just like the previews, just like the data tables that I showed you yesterday how to create. You go to add, you go to adding of the data, and you add the data that you would like to see in that configuration. Okay, let's go back to intersection preview and let's check what else can we do here. Okay, so we see that we have some that are above, some are below, and some are in direct collision. If you want to see only collision, only the clashes, you can click here, show only collisions, and now we have just the crossings where the distance is 0, meaning these are the clashes. Also, you can define collision tolerance. Let's say that the collision tolerance is 10 centimeters, basically 10 centimeters buffer around the pipe solid. Okay, enter. And now here it is. Now we have 15 clashes, and this is it. We have 0, but also everything that is 10 centimeters or smaller than 10 centimeters. Now this is treated as clash. Also, this is really nice function for filtering. For example, you have really huge networks, but you would like to check the crossings and clashes just on some place. For example, here, this is interesting part. Just select it like this using AutoCAD selection. And now I will turn off auto zoom now. We have only crossings or clashes here on this area. Or this is really nice. Let's select now with Urbano selection of arrays. Let's select one array, one channel. Let's select this array of the sanitary system like this. Let's switch to intersection preview 1 from 1 to 2. Here now we have some other data. For example, I put coordinates, really important data for crossings. We have terrain heights. We have which systems are crossing. We have which arrays are crossing. And I selected the array FK1.5. And I have the data about what is the crossing array and what are the stations. So this is important. And you can see that in this data table, it is sorted by stations. It's not just randomly put in this table. So if we now see this, so this is the station 7.68 of this channel. And everything as we follow it, everything is sorted by the array. If we select something else, for example, this array of the water system or something else, let's again select the sewage system because it's, let's select this one like this. And again, you can see everything is sorted by stations. Always nice to know that everything works in 3D. So let's do it one more time now for this system. Let's sort it by distance. And now we can see much more better because we are, everything is being drawn on a real terrain height. So in the example before, it was kind of, you know, we were too high to check it with the plan as well. And here the terrain heights are really low. So it's really nice graphic because you can see that immediately where this is in plan and also this is in 3D. Okay, and that's it. You can just go through the data table, and this is, you know, as long as you are in the preview, this will not be deleted. So you can zoom in, you can even select it like this. So these are 3D solid elements. You can, if you work in the Civil 3D, you can even open the object viewer and, you know, inspect something and stuff like that. So that is pipes with pipes. Let's go to pipes with manholes. This is really nice. You can see the shortest distance because the pipe is going below this manhole, as well here and as well here. And manholes with manholes. This is really interesting because these two designers, one was designing sewage system, one was designing water systems, you know, and the pipes are okay, but the manholes are too close one to another. Okay, let's now turn off this 3D. We will not fix this. We will not talk about fixing the problems anymore. You know now how to do it. You can move something in plan by moving the node, or you can go to profile and move the invert position, and basically there will be no more clashes. But let's now show this, and this is really important. Let's now draw new system. Let's say that this is all the existing, and let's pretend that there is no clashes. We will just we received this. This is clash-free model of the existing as-built state, and we will just draw our new system. Okay, I have some helping layers here as well. help point layer state. And I will just draw new system. Let's go to draw. Let's go to draw network elements. And because we learned yesterday everything to know about this function, we will just use some function that we didn't use yesterday. So connect automatically, it will be to node. It's remembered from yesterday, so be sure to change this. And now we will say, okay, I would like to automatically set pipe from pipe catalog, something that we didn't use yesterday. Let's say that we are designing water system, so I will use this PEHD pipes nominal pressure 10, and pipe will be, let's say, 110 millimeters. We can automatically assign the manholes, but I will not. For terrain elevations, we do not have Civil 3D DTM surface. We have Terraform. So if you switch to Terraform panel, you can apply this style and check this Terraform surface. Okay, I will hide it. So we will switch to Terraform, and we will use this surface, and we will use additional points. Always use it. For invert elevation, yes, import invert elevation, but referent pipe point, I will say top outer, so top outer pipe crown will be 1 meter below the terrain. Of course, invert elevation will be bottom inner or whatever, but we will say that the top outer point of the pipe is 1 meter below the terrain. That's what I was saying you yesterday. Yesterday we didn't assign the pipes, so we couldn't use this option. We always draw the bottom inner, which is invert. But you can also draw, for example, top of the pipe. This is really nice function. So, but you have to assign the pipe as well. So let's click now on draw, and I will use AutoCAD OSNAP to connect to the centers of these circles. And how I am picking, notice in this tooltip that terrain heights are automatically read from selected DTM surface, and also in the background the software is automatically calculating all the pipe crosses. Okay, so this is just to show you that you don't have to do anything special. You have to just design what you are designing. You can go to drawing of the profile. I will draw the profile for this one new array, which is basically the entire system. And let's draw it, and everything is here. So all the crossings, all the clashes are automatically calculated, and everything is showing like it is defined in this profile configuration. And just to show you, this is exactly, let's put also intersection. So here, this is now exactly 1 meter, because I said that the crown of the pipe, top of the pipe, is 1 meter below the terrain. And we have all these labels. We see which systems are crossed. We see the distances also here in the data table if you want to show it, terrain heights, and intersection point station on that profile. So really nice for some kind of analysis if you want to analyze crossings between existing infrastructure for the design purposes. Okay, so I will now turn off these helping points. I don't need these points anymore. And I will show you something else, and that is how the profiles and crossings are completely dynamic. So I prepared some predefined viewports here to show you simultaneously plan and profile. So this part here is this part here. So we have orange, magenta, and green system crossed here. Now I will just use move node function, and I will move this node, for example, here. Notice on the right how everything will automatically change. So all old crossings that do not exist anymore are automatically deleted, and all the new ones are automatically calculated and shown in the profile. Just see what amount of cross pipes we have here. So the software is taking care for you about everything. it's up to you just to design your system, and the software will alarm you about when you have a clash. You can have it in your profiles, or you can open your data preview for crossings and you can check it there. Okay, let's now show something else as well. Let's go here to profile dynamics, another viewport that I created here. And it's important to say that not just that this profile for this system that I'm moving is updating, all other profiles are updating as well. So if I move this node here, notice on the right how this is moving as well. So the complete model is automatically updating, and everything is completely automatic and dynamic. Okay, let's go back to plan view. Let's turn off this layer with the helping frames, and let's now see something else. For example, you don't want to see, when you go here to intersection preview, you don't want to see everything here, all the 5 systems here. Of course, you can turn just here in the data table. For example, you can filter it and check it, just my new system with storm, or my new system with drainage, or my new system with storm and drainage. But this is just a filter. What you can do is also create so-called clash test or intersection test. So you can go to system selection. By default, like I said, everything is testing with everything, but you can create a new test, and I will call it new system versus all other. Be sure to set it as current. And now, just like in Navisworks, you can say on the left, my new system, on the right, everything else. Okay, and notice now this. Let's go to refresh all the profiles for all the systems. So if you click on this icon, only the profiles of the current system will be updated. But I would like to refresh all the profiles for all the 5 systems. Go to this manager of the profiles, and here we can go to all the valid profiles, which is the systems which is the profiles for all 5 systems. Control A to select everything, or just okay, you cannot go on the right mouse button, but Control A and redraw. And now all the profiles will be redrawn. Okay, just wait for a few seconds. And now you will see that the program is now ignoring all other systems except for our newly designed new system and all other 4 systems. Because this is really important if you would like to test just your newly designed system with all other systems. You are interested only in crossings and clashes between your system and all other systems, and you are not interested in crossings between all other pipe infrastructure. So that is it, and now you can see that you can have only new system in the profiles, and the same is also if we go to our intersection preview. I will turn off auto zooming. Let's switch to intersection preview number 2, where we have our stations, and that's it. Now you see everything is also sorted by the stations. Also, let's put some kind of the label. So because we are now done with this project, let's go to intersection settings. Let's turn on automatic labeling, and let's have position label. In this position label, I have coordinates, terrain heights, and station of my new system. And like I said, everything is completely dynamic, the labels as well. So if I move, notice how the station and the label will also automatically update as well. Always you need to have some kind of a report. So of course, this data table can be copied. You can copy it. You can even copy it as HTML to get all these colors as well. And you can paste it to Excel. But if you need some specific report, you can go to reports. You can create a report configuration with the data. that you would like to have in your report. I selected this data. To add some other data or to change it, just go to this select data icon. You can define the custom names, and when we go to write report, you can open it, and this is it. So you have it for your new system. This is the data that we decided to have. We have X and Y coordinates, we have stations, we have terrain heights, we have data about all the crossing systems, so which system is crossed, data about the crossed system, so nominal diameter, crown depth of the crossed system, and the distance between the two pipes. Okay, I will save this report. Let's close it. And let's now, I will save also this, I will save this drawing as well, because I will send it to you. We are done with it for now. So let's go to save as. Okay, let's call it for systems final. And let's go back now to our Urbano Canalis drawing. We are not done with it yet, because I would like to show you one really nice functionality as well. Here, if I open my layer properties, I have one more layer, which is called CAD infrastructure. Let's turn it on. So these are just plain AutoCAD lines or polylines. Here we have polylines that represent some kind of, let's say, dry utilities. This is some power cables. This can be lines, this can be polylines, 2D or 3D polylines. Of course, you can create a new system, you can convert everything to Urbano, you can set the pipes, you can set the elevations on a constant depth below terrain, and everything can be done. But of course, we have better function for this, because if you just receive from some, I don't know, other company where these cables are located, on which depth below terrain, you don't have to convert it to Urbano just to analyze for crossings and for clashes. That's why we have a function that is called CAD element groups. If you open it, you can create a new group, or here you have one which is empty, one default. I will call it power. Here you can use layer filtering. You can select a layer from the list, or you can select it from the drawing like this. The software recognizes which layer this is. You can show just that one or multiple ones. And now you can say pipe group for these elements will be, again from Urbano pipe catalog, I will have PEHD pipes. Pipe will be, because these are some small power cables, I will use this 110 PEHD. Invert position of the pipe, meaning referent pipe point, again, I will say top of the pipe will be, you can use, if it is a 3D polyline, you can say use CAD element elevation, or in our case, these are lines or 2D polylines, I will say use terrain elevation from the section. So we'll have constant depth below terrain of 1. Sorry, not 1, I have it here, 0.5. 0.5. Okay, and just click on enter. And I forgot to select it, so be sure to select it, and you can select it like this, everything, because we are using layer filtering, and now you have it. So this is, we can treat it as virtual Urbano system, because now these lines and these polylines are treated just like any other Urbano system, because they have group, which is, let's call it a system name. We defined it a pipe, we defined it the pipe position, we defined it depth below the terrain, and everything is here. So let's click OK. The group is created, and now what we have to do is just refresh the profiles. To refresh the all profiles for multiple systems, we have to go to Manager. Again, Control A, redraw, and now you will see that automatically new virtual system group, CAD element group automatically appeared. We see this is a power cables, nominal diameter, depth below terrain, everything is here, and you notice that it is in the color of the layer from the plan. The same is for the systems. This is a feature that can be turned on or off. The default is on, so automatically everything is taken. The colors in profile are automatically taken from the color of the layer in plan. Also, if we go to our profiles for water system, you can see that the power cables automatically appeared in the profile for water system as well. And also, if we go to our intersection preview, okay, let's auto zoom it. We can sort it here, topology type, CAD element, power. So zoom it, you have it here. You can also draw it as 3D. Even though we started as plain 2D lines and polylines, you can draw it in 3D because, like I said, this is now just like some kind of virtual Urbano system. So you can auto zoom to it, you can preview it, and you can even analyze crossings, clashes, and distances in 3D between these different pipe infrastructures. Okay, so that's it about the pipe crossings and pipe clashes. And now we will generate 3D BIM model. To do this, basically, we have everything. Only thing that you have to do now is to export. And to export, you have to go to this BIM panel where we have functions for IFC export, Navisworks export, LandXML import and export, with which you can communicate, for example, with Autodesk InfraWorks, Autodesk Civil 3D. With IFC, you can basically go to any software like Revit, for example. And of course, with Navisworks NWC file, you can directly go to Navisworks. And of course, with IFC, you can also go to Navisworks as well, and also some other IFC and BIM softwares not from Autodesk as well. But when we talk about BIM, BIM is not just 3D model, it's also the data. So in Urbano, you can create data configurations that are stored inside of the application. So you can create these data groups once, and you can use them on all of your other projects as well. So let's create one data group, and I will call it geometry data. By default, it is just the name. So let's start adding the data for export. And like I said, this is saved in the application, so it will wait for you. So it's just enough to create it once. It will wait for you on all of your other projects. So let's, for example, just add some simple data like system name. Let's add the name of the channel or array. Let's say starting node name, ending node name. Let's go from geometry. I would like to have length in 2D, length in 3D. Let's also have from invert data group, I will have starting invert elevation, ending invert elevation. I will use slope data. Let's use from the pipe group. Let's use, for example, pipe group. Let's use pipe material, nominal diameter, inner diameter, outer diameter. Let's use maybe what else? Maybe this is enough. Okay, maybe, I don't know, let's go for the manholes as well. Let's add some data for the manholes. So let's say, let's use manhole material, manhole width. Let's use maybe manhole cover elevation, manhole bottom elevation, and also let's use manhole depth. And that's it. I think this is enough data. And now you can even give it some custom names, because this is how the data is called in Urbano. But when you export it to IFC, you would like to name it something different. For example, this array, I will call just array, like this. Starting node, I will call it like this. Ending node, I will call like this, just some shorter names. Slope, I will call it slope, and I will change the unit. So by default, it is in this per mile that we discussed yesterday, but I would like to have it in percent. So just multiply it with 0.1. And now when it is exported, it will be in different unit. So for the nominal diameter, let's also put it shortly like this, nominal diameter, it will be in millimeters. Also, let's give it a shorter name for inner diameter. Also for outer diameter, it's like that. Manhole material, manhole width, manhole cover elevation, manhole bottom elevation. Let's call this manhole depth. Like that. Okay, I'm satisfied with this data group. Let's create another one, and I will call this excavation data. And here I will export and put all the data about excavations. So here we have excavation data. So excavation volume, we can also put this data about the zones, but I don't need it, it's too much detail. Let's put sand bedding volume. Let's put pipe volume. Let's put sand backfill, ground backfill. So these are the backfill layers. We can also put formwork data, surface area of the trench. Also, let's find the data about the excavations around the manholes. So it is under geometry, under manholes, and here we can find it, manhole trench and excavation data. So let's put, I will put a manhole excavation volume and manhole filling volume above the manhole. Okay, so backfill. And we can also give it some custom names. I will call this manhole excavation volume in cubic meters. And this I will call manhole backfill volume, again in cubic meters. Okay, and let's create another configuration, and I will call this user data. And here I will add just this user data, year and pipe status. Let's click OK. Let's click OK. So now data configurations are set, and they are waiting for you for all of your other projects. And now you have IFC export, you have Navisworks NWC export. It is completely the same, You can, it's not the same, it's different format, but the function is completely the same. So if you want to export to IFC, you have to decide what you will export. So we will export both these systems, sewage system and water system. And we will also export the DTMs. I will use only this Civil 3D DTM because it's completely the same. Okay, and now the data. So for all systems, I will add geometry data because it's the data for both the sewage and the water. Additionally, for the sewage system, I will edit excavation data and user data. So now if you check, if we are under sewage, we have geometry data, excavation data, and user data. And if we are underwater, we only have geometry data. You can export it on absolute coordinates. This is for Navisworks. If you want to export it on small coordinates for Revit, you can use relative coordinates and set referent project point and set it to 0. You can also define some project data. For example, project name, let's call it Novi Sewage. We can give it some designer data, like I will put my name here. And this will not be written to nodes and sections, pipes and manholes. This will be written to IFC file. So this is really important. Also for the company name, you can put some data and some arbitrary data. Let's put here a data about investor. I don't know, some name. You can put I don't know, some street. Data, I don't know, designer. And you can put here some data that is really important for your BIM model. Now you can export each system to separate IFC file, or you can export all to one IFC file, what I will do here. Additionally, if you want to export to Navisworks NWC file, you can automatically create some Navisworks selection sets according to any data. For example, pipe material, I don't know, pipe diameter, you can create according to some user data. So you can automatically create Navisworks selection sets. And also you can export 3D solid elements of the trench excavations and backfill layers. Okay, let's now check our IFC file because we exported it. So it is located here. Here it is, the IFC file is here. Let's open Navisworks or any of other BIM softwares that you are using. I use Autodesk Navisworks. So just drag and drop it. So if you are using Navisworks, then maybe yes, it is better to go directly through NWC file. You have some advantages, but some investors always require this IFC file. So it's up to you what you will give to them. So I will just change the color of the background. And here we are in the Navisworks. Everything is here. We have our Civil 3D DTM surface. You can hide it, or I will just override transparency. So it is almost completely transparent. And here it is, Urbano systems for water and sewage. We can open also the properties dialog. Let's expand it a little bit. So we can check the data that we have put for the whole system. So it is here. So IFC person, IFC organization, everything is here, and also arbitrary data that we exported. So the data about the data about the investor, address, designer, data about application, everything is here. And also the data that we defined is located under each element. So you have the water system, you have the sewage system, you have this, so all the pipes, all the manholes, and you can go really deep inside of the model and check everything. So let's now check the data. If we hide this surface and select some pipe, for example, we have the tab geometry data with all the data about geometry. You see the slope is in percent because I multiplied it with 0.1. You have excavation data and everything is here. Also, if we pick on a manhole, let's select this manhole, for example, again, excavation data around the manhole and backfill volume. And also if we select, for example, a pipe, from water system, we have only geometry data. So you see again some custom data here as well. And also if we select here pipe, if we have this user data, this, let's call them GIS data, custom arbitrary data that we created in Urbano. Okay, so that's it from the BIM part of this training. I will save this as NWC file. Okay, we can close Navisworks now, and the next and the last topic today will be we are now completely done with this drawing, so I will save it, and now we will talk a little bit more about drawing of the house connections and storm drains. This is really nice feature because it allows you to draw house connections and storm drains that can be connected to nodes, but also they can be connected somewhere in between the nodes directly on the sections, and they will not break your sections in parts. So we have just one really simple example. It's the same area as before, the Novi Vinodolski. So for the practice, you can continue working on the main file, but I now created just some separate files so we can check something in more detail. So if we go to draw function, we have specific function for drawing of the service lines, meaning house connections and drains. We can open it, and the software is asking, what are you drawing? I will say house connections. You have to define the pipe, or you can define the pipe. I will use some PEHD pipes of 160. Change this default one because it's saved in the dialog from some previous, and you don't have to have this catalog. So I will use some from our catalog here, even though it's the same or similar. Okay. And for the DTM type, in this case, it will be Civil 3D surface. And now you have many different options how to connect it. I will connect top inner point of the main pipe to top inner point of the house connection. You can choose any of the points of the pipe. And for the house node, I will say that the depth of the invert is 0.8 meter below the terrain. And I will just choose the interactive option and just click on draw. And now you see, you can just start drawing and draw it interactively. Notice how the profile is automatically updating below. Or you can precisely define the position. So distance from the starting node or the distance from the ending node. If you tap tab on your keyboard, you can precisely define the distance from starting or ending node. Let's click, for example, 15 meters from the starting node, and I will draw it here. Again, let's click on tab. Let's click tab one more. And here I will input now 10 from the last node of this section. And let's draw it here. Okay. Also, you can draw your house connections that consist of multiple sections. So here, 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 like that. Okay, so this is the interactive way. You can also draw them automatically. You define the section length, you define the angle, and you define the constant distance on a section, and you can draw them automatically. Or you can convert them from existing AutoCAD elements, lines and polylines. So check this. You can also define some tolerance, because sometimes these lines can be not properly connected. You see, they are not snapping to the section. So if, and this can happen a lot of time, you can just define this tolerance. You can define it numerically, or you can define it graphically. For example, like this. But you can also do it here from the dialog as well. Again, we can use layer filtering. So I will use this layer. The software recognizes which layer this is. And now I can select everything. The software recognizes which layer this is. Okay. And when we click on draw, everything is converted. You see the profile automatically updated, and this is everything connected. The software automatically snapped to the closest point on the section. And now, really important thing, notice this. This is still one section. So house connection did not break the section, did not insert a new node. These are the characteristics of this house connections and also the storm drains. Of course, it's always better to connect storm drain directly to your manhole, but for some reason you can also connect it like this directly to pipe if you need it. Okay, so that's it. Let's now check our profile, and you can check and see that I defined that connection point is top inner point of the house connection to top inner point of the pipe. But also you can edit this. So let's do it. Let's go to editing, edit service lines and drains. You have your selection options. I will select just the first two, and I will change justify point, this point of alignment, not to be top inner to top inner, but axis to axis. Let's click apply and check it here. Now it is axis to axis for the first two. And why is this important? Because, for example, you define your house connections and now you have to edit your main channel. And you go to your function for input editing of the invert, or doesn't have to be invert, just like I told you yesterday. If you have your pipe, you can define here what is the reference point. And I will switch now from bottom inner. Check this. If it is a bottom inner, you are defining bottom inner. If you switch here to top outer, you are defining top outer, which is always nice when you have your pipes already defined. And I will just change the elevation or the depth. I will say that I would like to go here like this for some reason. And when I click apply, but also notice I didn't say in Urbano, you can also draw the profiles in the opposite direction. So I draw this in this direction. So that's why it says that the slope is negative. It's not negative slope. It's just that the profile is drawn in the other direction. I will show this as well. So, and now you see that when we moved it, we can move it again. For example, back here, apply, you see that the house connections are always following the main pipe like this, and you see that the first two are connected axis to axis and the other ones are connected top inner to top inner point. Also, maybe it's not important to keep telling you this all the time, but everything is dynamic also in the plan. So for example, if you would like to move the position for some reason, you go to function for moving of the node, and now you can also select this connection point. So if you move it, notice how the profile is automatically updating. You can also move it to another section and the profile is still dynamic. But one thing you have to know, when you are moving a node on a main channel, the house connections will remain connected. Let's do it, for example, like this. Everything will remain connected, and you see these magenta points. These points are telling you where will be the position of the new house connections. What is kept? Kept is the fixed distance from the fixed node. So I'm moving this node, but you can see that the distance from the node of the section that I'm not moving is fixed. But if that distance cannot be kept, for example, if I move this node here, you see that the purple point will disappear. Let's move this, for example, here. And now you will see that this is not connected anymore. But no problem, just select it, just put where you would like to put it, and they are connected again. Okay, let's now go back to plan view and let's draw all the profiles for all the house connections. I have here a configuration for that in the scale 100 to 100. I will select everything, but not everything, only the subsystem elements. In Urbano, we call subsystem elements, so house connections and storm drains, we call them subsystem elements because they are not breaking the sections in two. So subsystem elements, let's click on draw and let's place these profiles. I will place them here. And you can see that you can draw the profiles for the house connections as well. And we see for the first two, we connected axis to axis. And for the other ones, we connected top inner to top inner. But let's also check what else can we do. Let's go to editing, edit service lines and drains. And some users like to connect it like this with some alignment offset. Let's put alignment offset 10 centimeters. And we will say on the main pipe, go from top outer, and from the house connection, go bottom outer. Let's apply it. So now you will have the fixed distance here. Let's say, let's turn on The fixed distance here, it will always be 10 centimeters, or you can also have fixed slope. You can have fixed slope and wherever it ends. And in this way, your house connections will be above the pipe because there is some special structure that you can put, like a pipe, a vertical pipe that will connect directly to pipe. You can even put that pipe. If you go here to editing, you can define it. Here, it's a vertical pipe, so it's more like a manhole. So inside of the manhole catalog, you can create one really small manhole, like vertical pipe of, let's say, I don't know, 200 millimeters, and you can choose it here from the manhole group. You can choose that type of the manhole, and you can define what is the depth of that manhole below the terrain, because these special structures do not go all up to the terrain. They end up, let's say, 0.5 meter below the terrain. So even that can be done. Okay, let's save now this drawing so I can send it to you. I will save it as house connections final. And now with the same function, we will also draw the storm drains. Here I have also one custom block for the drains. So I will copy it just like I showed you yesterday. We will go to our installation folder where I showed you yesterday. So the version that you have installed, you go to our we go to our nodes folder, and here I will paste this custom block. So we have manhole red and manhole drain. Okay, that's why because here I will open now this last file today. If we go to drains here, you see that this is the project, the project that I already showed you that I used on the webinar, and this is a real project. And according to this project, the designers used some custom blocks. So you can go to your stylings, and for the blocks, for the let's find it, the drains. This is the default block, but I will use this manhole drain with the double grate. Okay, let's click OK. And we have these lines representing the positions of the storm drains. So let's now go to draw of the service lines and drains. This time we will be drawing drains. We will use some pipe. Let's use, for example, again, PEHD pipe of 250. Okay, DTM type will be Civil 3D finished ground. Here we have finished ground and existing ground surfaces. And now I will use constant slope of 20 per mile, which is 2%, and the depth of the drain node will be 1 meter below the terrain. Again, I will use layer filtering like this. Select everything, convert. Everything will be converted pretty quickly. Let's check it. And now you see that we have pipe, and we also have these custom blocks that we defined. If you need to rotate the blocks in plan, you can do it with this icon, interactive node rotate. Select it and rotate it, and you can align it to be really nicely aligned with your catchment areas, with your road edges, with your curbs and stuff like that. Okay, and also let's now draw all the profiles for the storm drains. Again, configuration in 100 to 100 scale, all the subsystem elements. Let's click on draw. Let's place them here, and we can see how they look like really, really nicely. You see that everywhere the constant slope of 20 per miles or 2%, and the depth of the invert in the drain is exactly 1 meter. Okay, we have to define the manhole here yet, so let's go to defining of the manholes. I will use from the manhole catalog simple structure of 700 millimeters. I will say that the manhole depth below the pipe is 1 meter for the sedimentation tank. And also I will say that the manhole bedding is 0.2. Okay, let's select all the subsystem elements, in this case, all the drains, and let's click Save. And now we have it. This is it. As you can see, we have exactly 1 meter this sedimentation part, or I have to start from the bottom inner, sorry. So this is 1 meter, and also this is 1 meter with the constant slope of 20 per mile. And the last thing, let's create one really nice report. This is the report for the drains. It's basically not a report, but it's a configuration. You can have it, you can use it. I will send you this file. Just select it, select all the subsystem elements, and here it is, all the data about the drains, names, coordinates, grade elevation, outlet elevation, bottom elevation, manhole inlet elevation, section length and slope, and also to which manhole this storm drain is going. If you want to copy it, you can copy it. You can go to Excel or any other Microsoft application. You can paste it, and that's it. Okay, we are now done with everything that I prepared for you today. Tomorrow we will talk about hydraulic calculation, about the definition of catchment areas, pipe sizing. We will even export to SVMM and stuff like that. And also I will show you the part that I was planning you to show you today, but I will show you tomorrow how to use different profile configurations and how to edit your profile configurations and some other really nice cool stuff about the advanced editing of the labels.